What if I told you that beneath the icy crust of a moon orbiting Jupiter right now, there could be more life than in all of Earth's oceans combined? While we've been searching the stars for alien civilizations, the answer to one of humanity's greatest questions might be hiding in our own cosmic backyard. Today, we're ranking every single moon in our solar system by their potential to harbor life. And trust me, number one is going to blow your mind. Our solar system contains over 200 moons, each with its own unique characteristics, and some of them are far more promising than you might imagine. Before we dive into the rankings, let's understand what scientists look for when assessing the potential for life. 3 key ingredients top the list: liquid water, energy sources, and organic chemistry. With these criteria in mind, let's explore these fascinating worlds. Starting at the bottom of our list, we have the small, irregular moons of the outer planets. These include the dozens of tiny captured asteroids orbiting Jupiter, Saturn, Uranus, and Neptune. Moons like Ananke, Carmi, and Pasiphae around Jupiter are essentially frozen rocks with no atmosphere, no geological activity, and surface temperatures hovering around -200 degrees Celsius. These inhospitable chunks of ice and rock offer virtually zero chance for life as we know it. Moving up slightly, we encounter Mars' 2 small moons, Phobos and Deimos. These potato-shaped satellites are likely captured asteroids, measuring just 22 and 12 kilometers across respectively. While they orbit closer to potentially habitable territory than the outer system moons, they're simply too small to retain heat, have no atmosphere, and show no signs of liquid water. Their porous, dusty surfaces are bombarded by radiation, making them biological dead zones. The inner satellites of the gas giants come next in our ranking. Moons like Métis, Adrastea, Amalthea, and Thebe orbit so close to Jupiter that they're constantly bathed in intense radiation from the planet's powerful magnetic field. Similarly, Saturn's innermost moons like Pan, Daphnis, and Atlas exist in the planet's ring system, where any potential for life is crushed by extreme conditions. These moons are geologically dead and offer no protection from radiation. Earth's moon sits in the middle to lower portion of our rankings. While it's the most studied moon in the solar system, and once showed volcanic activity, it's now a geologically dead world. The moon has no atmosphere, no magnetic field, and no liquid water on its surface. However, recent discoveries of water ice in permanently shadowed craters near the poles and the potential for subsurface water deposits give it a slight edge over completely barren worlds. Still, the lack of energy sources and extreme temperature variations make it highly unlikely to support life. Neptune's largest moon, Triton, enters our top tier of potentially interesting worlds. This is one of the coldest objects in our solar system, with surface temperatures of -235 degrees Celsius, yet it's geologically active. Triton has nitrogen geysers that shoot material 8 kilometers into its thin atmosphere. Scientists believe it has a subsurface ocean beneath its icy crust, kept liquid by tidal heating from Neptune. While extremely cold, the presence of liquid water and geological activity places Triton in the conversation about potentially habitable moons. Saturn's moon Enceladus rockets up our rankings as one of the most exciting candidates for extraterrestrial life. This small, gleaming white moon is only 500 kilometers in diameter, but it punches well above its weight. In 2005, the Cassini spacecraft discovered enormous geysers of water vapor and ice particles erupting from cracks near Enceladus's south pole. These plumes contain salt, organic molecules, and even molecular hydrogen, suggesting hydrothermal activity on the ocean floor. Beneath its icy shell lies a global ocean of liquid water, possibly 10 kilometers deep. The presence of hydrothermal vents, similar to those on Earth that teem with life, makes Enceladus one of the best places to search for life beyond Earth. Jupiter's moon Europa claims a top position in our ranking. Slightly smaller than Earth's moon, Europa's surface is covered in a smooth shell of water ice, crisscrossed with mysterious reddish-brown streaks and cracks. Scientists are confident that beneath this icy crust lies a massive saltwater ocean containing twice as much water as all of Earth's oceans combined. Tidal forces from Jupiter's immense gravity keep this ocean liquid despite the moon's distance from the sun. The ocean is likely in contact with a rocky seafloor, where hydrothermal vents could provide both energy and nutrients. Recent observations suggest water vapor plumes erupting from Europa's surface, similar to those on Enceladus. NASA's Europa Clipper mission, launching soon, will investigate this moon's habitability in unprecedented detail. Saturn's largest moon, Titan, secures a spot near the very top of our rankings for entirely different reasons. Titan is the only moon in our solar system with a thick atmosphere, even denser than Earth's, composed primarily of nitrogen with clouds of methane and ethane. It's the only world besides Earth with stable liquid on its surface, though instead of water, Titan has lakes and seas of liquid methane and ethane. Beneath its icy crust, Titan likely harbors a subsurface ocean of liquid water mixed with ammonia. But what makes Titan truly unique is its complex organic chemistry. The atmosphere is a laboratory for prebiotic chemistry, producing complex organic molecules that rain down onto the surface. Scientists speculate about two possible forms of life on Titan: water-based life in the subsurface ocean, or exotic methane-based life in the surface lakes. This dual possibility makes Titan extraordinarily intriguing. But there's one moon that stands above all others, and that's Jupiter's moon Ganymede. As the largest moon in the entire solar system, even bigger than the planet Mercury, Ganymede has something no other moon possesses: its own magnetic field. This suggests a liquid iron core, making it more like a planet than a moon. Beneath its icy surface lies not just one but potentially multiple layers of liquid water oceans, separated by different forms of ice. These oceans could contain more water than Earth's entire hydrosphere. The magnetic field provides some protection from Jupiter's intense radiation, and the potential for chemical interactions between the rocky core and liquid water creates conditions that could support life. Recent observations by the Hubble Space Telescope and the Juno spacecraft have confirmed the presence of a vast subsurface ocean. With NASA and ESA planning missions to study Ganymede in detail, we may soon discover whether this giant moon harbors the first extraterrestrial life we've ever found. The search for life in our solar system has shifted from the surfaces of planets to the hidden oceans of moons. These worlds remind us that life doesn't need a planet like Earth to exist. It needs water, energy, and chemistry, and several moons in our solar system have all three. As our technology advances and new missions launch to these distant worlds, we stand on the brink of potentially answering the most profound question humanity has ever asked. Are we alone? The answer might be waiting for us, not around a distant star, but orbiting one of the giant planets in our own cosmic neighborhood.